Okay, this is page 147, question number 45. You're given x squared plus y squared equals 36, and you're asked to find d squared y dx squared. That's the second derivative. Okay, so we're going to start by taking the first derivative of this with respect to x. So I'm just going to write out that that's what I'm doing. You don't have to write this step, but I'm just writing out that I'm taking the derivative on both sides. Okay, the derivative with respect to x of x squared would be 2x. The derivative with respect to x of y squared is 2y dy dx. That's the chain rule that I'm applying. And then the derivative with respect to x of 36 is 0. Okay, I'm going to solve for dy dx by subtracting the 2x over to the other side. So now I have 2y dy dx equals negative 2x. I'm going to divide. So dy dx is negative 2x over 2y, or dy dx equals negative x over y. That's the first derivative. All right. What the second derivative means is I'm taking the derivative of the first derivative. So that means I'm taking the derivative with respect to x on both sides of that first derivative equation. So the derivative with respect to x of dy dx, that's when I write d squared y dx squared. Now to do the derivative of this right-hand side, I have to recognize that it's a quotient. So I'm going to have to do quotient rule. So remember quotient rule? v du minus u dv all over v squared, where u is the numerator and v is the denominator. All right, let's try it. So the denominator, y, times the derivative of the numerator, negative 1, minus the numerator, negative x, times the derivative of the denominator, which is actually dy dx. I have to apply implicit differentiation. That's the chain rule. And it's all divided by the denominator squared, so y squared. All right, I'm going to clean that up a little bit. So this first part, y times negative 1, I'll just write negative y. This part here, I'm going to write positive x times, and then this says dy dx. So I go back and look. Well, what's dy dx? It's negative x over y. So I make that substitution. And then y squared on the bottom. Okay, let's clean up a little bit more. So now I have negative y, and then it looks like I'd have a negative x squared over y squared. That looks pretty good, but I don't like to see a fraction inside a fraction, so I'm going to multiply the top and the bottom by y. All right, if I do that on the top, I have negative y squared minus x squared. I just distributed the y through the numerator. On the bottom, I have y cubed. Now that answer looks pretty good, and it fits the requirement of the problem, which said to express it in terms of x and y. But if you look in the back of the book, it's not what the back of the book says. So you're starting to think, okay, well, what the heck happened? Well, here's the key. Go back to the original problem. In the original problem, let me write this down here, x squared plus y squared equals 36. If I multiply through by negative 1, then negative x squared minus y squared equals negative 36. Well, look at that numerator. That is negative x squared minus y squared. So I could make a substitution and write that as negative 36 over y cubed, which is an even simpler form of the answer. And that's what you'll see in the back of the book. Okay, that may seem like kind of a little trick there, and it kind of is, but I do know that on the AP test, on multiple choice questions, they do sometimes do that little trick and write the final answer this way. Again, you can only do that if there's a substitution you can make there from the original equation. Okay, hope that was helpful.